Hi, my name is Madison Brichter, and my group went over standard atmosphere. So this is my group. We have Caitlin, myself, Ronald, and Adam. What is standard atmosphere? So standard atmosphere is the pressure at sea level here on Earth, and it is measured in pascals. This means that vertical column of air with a base area of 1.00 meters square exerts a force of 1.01 times 10 to the fifth newtons due to its weight, as the visual on top shows. This also corresponds with the 5 layers of the atmosphere and how we can understand our Earth. So what are the relevant fields associated with standard atmosphere? There are plenty of fields that are affected and or relevant to this. A couple examples would be meteorology, for example. With weather systems, meteorologists are able to better understand weather and predict it earlier and to warn the public sooner, which is an advantage. Fluid dynamics is relevant because of Bernoulli's equation with faster speeds meaning lower pressure. And for an example of this is when an airplane is going faster, the lower the pressure it has going against it. For thermodynamics, it is relevant for potential thermal energy in different altitudes, and this corresponds with the understanding of the higher you go in altitude, the lower the pressure is, and also the higher you go, the colder it gets, meaning the colder it gets, the lower the pressure. Aerospace is relevant due to conditions of flying and flying patterns. This lets the engineers know how and when they should fly, like how low, how high, and how it will affect the aircrafts and how to keep pilots safe. So who was Evangelista Torricelli? So he was a scientist who was born in October of 1608 and died in October of 1647 and grew up in Italy with his family. He worked for Galileo very closely and was to become his predecessor when Galileo died, which did happen. Torricelli discovered the idea of atmospheric pressure using the mercury barometer and also proving that vacuums existed. Another scientist I would like to highlight is Blaise Pascal. He was a scientist who was born in June of 1623 and died in 1662. He focused on physics, religious philosophy, and math. Now, his background in mathematics is really important because he put the mathematical equation on the standard atmosphere for us to understand. And so he worked off of Torricelli's work to further the explanation of our standard atmosphere. The original experiments were with Torricelli. He used mercury, and he created the mercury barometer with weight pressure of water and or air, creating the vacuum, and it sucked up the mercury through that tube right there in the middle. For Pascal, his experimental process was a little bit different, but going off of Torricelli's work, he used the mercury barometer that Torricelli created and actually had his brother-in-law go to the top of this volcano in France to prove that the higher the altitude, the lower the pressure. And with this information, he created hydraulics.
Hi, my name is Adam Callahan, and I'm going to be reading off some of the slides. Complications faced by Torricelli. Some of the difficulties he faced included, at the time of his experimentation, there was almost a complete denial of the concept of a vacuum. The people of the time could not really wrap their head around the fact that air existed. Air had weight, air had mass, they could not see it. So he did these experiments with his mercury tubes, and based on the fact that most people did not even understand that air was a thing, most of that stuff went mostly unaccepted for a long time. He was also using mercury, which of course now we know is severely toxic. And the biggest hurdle he probably faced was the fact that he was trying to measure something that no one had ever understood or measured before. The motivation for his experiments was to understand the behavior of suction pumps and why they could only lift water for a little higher than 30 feet. They were confused by this, and eventually it led to the discovery of the fact that air had weight. We use a more modern experimental process now. Our biggest tool in our arsenal is probably the weather balloons. We're able to use those to reach high altitudes and collect information regarding pressure, temperature, things that we can measure far more accurately now than Torricelli could have. And obviously the difference in the modern approach is going to be just the sophistication of the equipment mostly. Torricelli was, of course, using homemade tubes of mercury with bubbles in them to measure pressure and displacement by the air, whereas we have electronic and digital barometric sensors.
Future expectations. As the temperature changes, there will be a shift in altitudes. Things like greenhouse regulations and polluted layers may become incorrect data due to changes in the climax. Example question. How does the atmospheric pressure change with altitude in standard atmospheric model? Why is this relevant? Standard atmosphere is used as a baseline study for climax weather changes. Planes rely on standard atmospheres so that they can know the pressure data, such as things like rockets and other aircrafts. What are the benefits of understanding the question given? Improves rocket performance. Altitude measurements, great to have for future learning. Right process of question. Define the question. Why does the question matter? How can this question help you learn about it? What can this question teach you? Uniqueness of the question. This question is unique because it shows that applications to the real world scenarios and how it affects future outcomes of all kinds of scientific studies.
Hi, my name is Caitlin Roberts, and I'm going to be reading some of the slides of our group project regarding standard atmosphere. So, slide 5.2, relevant formulas and constants. Key constants include standard pressure at sea level, standard temperature at sea level, and the acceleration due to gravity. Formulas are the perfect gas law, which is listed below, and the temperature versus altitude, which is also listed below. Slide 5.3, the solving process. Atmospheric pressure decreases with altitude. Because of this, it depends on the change of the temperature. Using the above equation will result in answering questions based on meteorology discussions. This visual shows us the layers of the atmosphere pressure curves, showing the change in pressure relating to altitude. Slide 5.4, solution correct, applicable to topic. The solution to the question would be that as altitude increases, the pressure decreases. We know this because the air is a gas which is all around us and exerting pressure. The higher we go into the atmosphere, the thinner the gas molecules get around you. Air gets colder as you get higher into the atmosphere. This means that lower temperature plus density equals lower pressure. Slide 6.1, additional information. Standard atmosphere is used globally to better understand our Earth and patterns it shows. It is used by scientists and engineers to help the global population. The 5 layers of the atmosphere have all different effects on weather and maintain life on Earth. Slide 6.2, student interest. Adam, he says, I think the most interesting thing I found out was Torricelli's reliance on mercury for his experiments. I know other scientists of the time were using it actively, but I didn't realize the first prototype barometers were mercury-based. Ronald thinks how big of an impact standard atmosphere has on life, like how we can predict the weather and be able to fly, was the most interesting thing. Madison found it interesting that Torricelli was the first to prove that vacuums do in fact exist and that air does not have weight. Meet Caitlin. I found Torricelli's concept of the Earth being submerged in an ocean of air fascinating. This reflects the constant pressure exerted by the atmosphere. Overall summary, slide 6.3. The standard atmosphere model represents the weight of air, temperature, mass, and density. All of these work together and affect one another to change weather and better our understanding of our Earth's atmosphere. Torricelli was the scientist that proved that natural vacuums do exist and that air has weight and therefore mass. Mercury was his choice in his unknowledgeably poisonous experiment. Without this, there would have never been, or perhaps a delay in advancements when it came to other fields understanding our world.